Welcome back. So let's discuss molar concentration. Right. So first let's discuss regarding volume and concentration of solutions. So what is the solution? So what is the concentration? So concentration is this one. Concentration is of a solution is amount of solute present in it. So you can say the amount solute dissolve in a solvent to make a solution of 1 dm cube, right? So solute is a, now in this we have two things. What is solute? So solute that dissolve to make solution, right? And solvent is your water. So when I'm saying a concentrated solution is has a higher concentration of solute. So when I'm saying concentrated solution, right? So concentrated solution has two things, solute and solvent. Solvent is water, solute is, let's say, sugar. So this is more and this is less. Dilute solution. What do you mean by dilute solution? So dilute solution also have a solute and solvent. Solvent is water, solute is, let's say, sugar. Here it is less, this is more, right? So these concentrations, what I'm talking about, less, more or high, we can expressed in moles per unit volume, mass per unit volume, or parts per million. These are the three ways we can express. So let's first discuss about moles per unit volume. Fine. Now when it comes to moles per unit volume, what is this? This is written in a formula, that is concentration equals to number of moles of solute, that is given in mole, divided by volume of solution, which is given in dm cube. So the unit will be mole per dm cube, right? So you must make sure you change centimeter cube to dm cube. How to do? By dividing by 1000. In the question, this is given in centimeter, convert into dm cube by dividing, right? So we can say the formula here also, we can apply a triangle, right? So this is moles, concentration, and volume. That means I can write in short form NCV. So if you want to calculate concentration, you have to V divided by N. If you want to find moles, N equals to C into V, right? Like that you can apply how we have done in the previous. So let's calculate a question. Let's calculate one. So question is calculate mass of NaOH required to prepare, let's say 250 centimeter cube of a 0.2 mole DMQ solution. How to do? Very simple. First, what you do? First, you use the formula triangle and find the moles of NaOH needed. So, can we say number of moles equals to concentration into volume? That means 0.2 into 0.250, which is 0.050 moles, right? Now second, what you need? Molar mass you have to find, right? So for molar mass of NaOH will be how much? So Na is 22.99 plus 16 for oxygen and 1.01 for hydrogen. Total it comes to 40 gram mole inverse. Now you have to find the required mass. So required mass is equals to moles into molar mass. Done. So moles is 0.050 into 40, which will come around 2 gram. Answer. Understood? Now let's go to the next way of measuring it. Second was mass per unit volume, right? This is the second way. So sometimes it is more convenient to express the concentration in terms of mass per unit volume, right? Here also the formula is concentration is equal to mass of solute given in gram divided by volume of solvent that is given in DMQ, right? So to change the concentration, now here also to change the concentration from mole DMQ to gram DMQ, what you have to do? So multiply the moles. How to do this? So you have to multiply the moles of solute by its molar mass, right? That means mass of solute that is given in gram will be equals to number of moles into molar mass, that is gram mole inverse, right? The third method is ppm, parts per million. So when we are expressing, this is also a way. So when expressing extremely low concentration, expressing extremely low concentration, right, then we use this parts per million, right? So this unit is used. ppm is used. Also called parts. So this is useful when giving a concentration of pollutants in water, right? When we calculate the pollutants in air or water, right? So the big question is how to define 1 ppm. So 1 ppm is defined as that a mass of 1 mg dissolve in 1 dmq of water. This is the definition. Since 1 dmq weigh 1 kg, you can also say it, right? So we can also say that a mass of 1 mg dissolved in 1 kg of water, right? Or you can say 10 to the power 3 gram in 10 to the power 3 gram, which is the same saying the concentration is 1 in 10 to the power 6 or 1 in a million. This is important. Let's discuss few examples to understand these methods. Let's say the question is the concentration of chlorine in pool should between 1 and 3 ppm. Fine. Calculate the max mass, that is in kg, of chlorine should be present in an swimming pool of size 2.5 million liters. How to solve? Easy. First step, calculate total mass in mg, assuming 3 ppm, that is 1 liter is same as 1 dmq. You have to remember this. So can I say this will be 3 into 2.5 into 10 to the power 6. That means 7.5 into 10 to the power 6 milligram. Now second step is convert the mass into kilogram. Now we have to convert mass into kg. That means 1 mg equal to 10 to the power minus 6 kg. So this will be 7.5 into 10 to the power 6 into 10 to the power minus 6, right? This will be 7.5 kg. This is the answer. This is how we can solve questions. Thank you.